Hello, welcome to my YouTube channel. And today we are going to discuss about our final semester project, line following robot. And here's my role ID, 191037. So first of all, we'll have a brief introduction of what basically a line following robot is. So basically, our bot that is made to follow a line is known as line follower. The line can be either black or maybe white, and on the surface on which the robot will be moving can either be black or maybe white. So these days, all the robots are being made with the help of some microcontrollers known as Atmega 328P. They can be Arduino Uno or maybe Atmega 2560, and there are multiple variants that can be used in our project. So since even making a simple line following robot can cost up to a few thousand, but the circuit is too complicated and difficult to understand. So we have a basic line following robot with some basic concepts. Um, there are two types of line following in which IR sensor will either give one value on white surface or maybe one value on black surface. So here in our project, the fundamental principle was to detect the black line on the white surface, which will give a higher input to the controller, and it will make the motors to follow the right track. So these robots are designed to follow the line or path that is already being fixed by the user or by someone, and the path may be a straight line or maybe some curved path or maybe in zigzag form as according to our requirements. So to detect the lines on which our robot will be moving, and different type of sensors are used that will sense the line. And here the fundamental principle will be like that the light will fall on the line, and then the receiver will receive the light back to give the inputs and then make the specific decisions as per our requirements. So the robot processor is basically a microcontroller in this project, and we are using Atmega 2560, which would be reading signal from IR sensors and then compare their values based on our logic, and then they will send the signal to motor driver, and then they will make the robot move forward. So now we will go to our goals that were the goals and main basic objectives of this project. So first of all, it was to design a line following robot, and then to make a PCB design, and then the line should be followed by our robot, and the robot should be capable of sensing some obstacle if any obstacle is placed in front of our path. And for it, we use ultrasonic sensors, and it should be fast and accurate. And then we had to design it on Proteus and then PCB simulations and all that. So these are our components that we used here, which includes IR sensors. And here in our project, we used a strip of IR sensors that were aligned together, and then we used recycled base, tubeless rubber tires, nylon all direction wheel, motors, encoders that were there to um, record the speed of it. And here we had one more objective that was to record all the readings, like voltage readings, and then speed of our robot, and then current measurements, and then the goal was to send all the readings on our LCD module. And then the task was to save this all in our SD card module. So, for that purpose, we use SD card module, Arduino Mega 2560, lithium potassium ion battery, a current sensor, a voltage sensor, and LCD. And then moving further, this was the chassis that looked like this. here we had our tires, motor, and this was the connection for battery, and then all these some material in it. But in our project, we used double chassis because we were using four tires, and the power was given to all four motors altogether. So it gave a push to our um, robot with some high speed. And here was our PCB board that we designed. Um, we faced quite a lot of hardships in designing this PCB because first of all we used a PCB board that was of some low quality and it was broken, and then again we had to get another PCB and it was not etched properly because our solution was not concentrated. So after learning from all the mistakes, we got this PC board, and it was quite good, and it was etched properly. And here we had some minor disk activity that we checked from our DMM. So we had to solder a little while wire at this spot to make the connection work properly. So here the motor specifications in our project was that we had to use a DC motor of voltage 3 to 6 volt, and then speed of 120 RPMs. Current ratio would be 190 milliamperes to 250 milliampere, and the maximum torque that would be obtained was from 800. So now if we talk about our IR sensor module, so we use three infrared sensors in our line hauling project. That was in our and then the first sensor was placed at the left position, and then a middle, and then in the right side of it. And this working of the sensor were like that. Uh, Three different modules of the infrared sensor were mounted in the form of the robot. IR sensor module made up of two diodes that one of them sends infrared rays and the receiver will receive these rays as they are deflected back to the surface. Infrared LED emits infrared radiations, and these infrared radiations, which are not visible by naked eye, cause the surface in front of the receiver LCD of the sensor, and surface bounce back the infrared radiations. And then the reflection of the radiation depends on the ability of reflectivity of the surface on which the robot is moving, and then the amount of the light being reflected varies every time. So this was the our sensor working, and here we have a visual explanation of how the IR was working. So here we had IR transmitter that will send IR radiations to a surface, and then it will be reflected back, and it will be received by our IR receiver. So that was the light, and if it was this black surface, so as the black surface will absorb the radiation and will not send the receiver, and we coded it that when receiver will not receive any radiation, then the input will be high and the robot will stay on that path. So moving further to our controller, we had Arduino Atmega 2560. So Arduino Atmega 60 is a microcontroller that we use to program our robot, and it is the main central processing unit of our robot, and it's kind of brain of our robot to make some decisions. Now in our Atmega we have several input and output pins, so it means that we can transfer a lot of data as an input and output at the same time. So here in Atmega, we had more RAM as compared to Arduino Uno, and here we had 54 digital output pins and 16 were the analog pins. So this microcontroller is basically used for the complex projects, as it has a microcontroller and has high performance with low power consumption, and it uses advanced RISC architecture. And this system programming goes on well chipboard program, and for it we used Microchip Atmel Studio to code our program. So this was our another component that was motor driver, and here we had our input pins, and here our output pins, and this was used to move our our motors that will be performing our task as according to our requirement. Now let's move on to the block diagram of our project. So here is the block diagram of the process that concludes our whole working of our project. So here was the sensor array that would behave as an input system, and then there would be a comparator IC that will process the signals and will transfer uh, chain and binary data, and then it will go into a processing system that will be basically processing will be done in microcontroller that will make multiple decisions that which motor should work and which motor should not work to move it in either right direction or maybe in left direction if the path is in curve way. So here our motor IC was L293D. Moving further, if we talk about our applications, so line following can be used to deliver mail within an office building. It can also be used to deliver medicines in a hospital, and this technology has been suggested for running buses or other mass transit systems and maybe part of automobiles car navigating the freeway. So the line following can be used also in guidance system of industrial robots. Moving on shop floor. Now we'll move to our um, report where I'll discuss. Um, so here we have the data sheet of our IR sensor in which we have IR emitter LED and then IR receiver, and then we have a kind of screw here from which we can adjust our um we can from here we can adjust our distance, which is basically for proximity of sensor to send the radiations, and then here's our power LED which will show either our sensor is working or not. And then here we have obstacle LED, and that if it detects something, so it will pass a higher value. And here we have three terminals of it, where one is VCC, the other one is ground, and then the output terminal of it. And here we have the information regarding our pin control indications, that how it will be working. And then moving further, we have the datasheet of ultrasonic sensor, in which we have VCC terminal, and then echo and ground, and then twig. So basically here we have the functioning of it. The echo pin is a receiver pin, trigger is trigger pin that will send the ultrasonic waves, and the other one is receiver, which will receive the output and then make some decision, and then pass the instruction to controller, from which it will tell it which will tell the robot that there is obstacle and we have to avoid it, so it will change its path. And then the ground terminal is power ground. And here the information about is that it will operating voltage is around 5 volt, and then operating frequency is 40 kilohertz, and the farthest range that can be detected is 4 meter, and the nearest range is 2 centimeter. And here are the dimensions of it, that how our project will be detecting it. And here we have the data sheet of our controller, where we have the input terminal and ground pins, and then analog pins, and then digital pins. Along with it, we have here we have our chipset from where the instruction coding will be sent, and moving up here, we'll have the point where the from where the instruction will be coded into the controller, and move it for here. And if we move further, then we have another component that we used in our project, that was deal full driver. And all the deals are given here with the block diagram of it. And moving a little more further, for all explained in the PPTs. So we won't waste our time here. And moving a little further, we can see that here is how actually we controller looks like. It has multiple pins at this side and here, and then we should put in and then many uses out from where the instruction will be sent from laptop to computer. And then there's a regulator, and then external post in case the controller isn't receiving any power supply from the NL source. And then the motor driver was already described, that it has dual full bridge driver, which is specifically designed to accept standard transistor to transistor logic and then drive motor for robot. The two enable pins are provided to enable the motors on or will or disable it. And the working principle of L298 is that it can be used to operate two output power stages, and the state of the motor driver, which is used to operate any kind of load or motor. In our case, its configuration is known as bridge configuration, and it can operate the motor in differential or maybe in common mode depending on the inputs of the states. So this senses the output that is flowing through the bridge, and then an external resistor allows the amount of current that is flowing from the motor driver. And then we have speed control motors that were used on 4 points of our project, in which it was perceiving the data from microcontrollers as per our um, inputs, and then it was giving outputs that either it should make a decision to turn right or maybe to left. And here in this we have the codings and logic for our code. Now here we can see that it would be moved to left and then right with the several conditions. Now we'll move to our hardware. Uh, So this was how our PCB looked after etching it, and then after combining all the components together. And this is all the code that was included, that was sent to our robot to follow, that is given in the report, and we will attach the link of the report in description below. This is the code that you can use, and now I will show you the hardware of it and how it was working. So, so this was our hardware, in which we have a microcontroller here, and this is our components that we just connected by connecting wire and then compile it. And here we have our LCD module, and then potentiometer that was used to control the controls of the LCD. And here we have our encoders, and then here is our motor driver and the current sensor, and here is the shape of our IR sensor that were used to sense the that was used to sense that if there it is on the right path or not. And then here we have this are for our ultrasonic sensor that was used, and this one is basically the wire that is used to transfer the instruction from our system to hardware to for to process it. And this one is the microcontroller, and we just placed it upside down where all the connections were made, and then we soldered this microcontroller with the PCB board so it won't move away from the board. And the we used the pins that were required by us, and then we used jumper wires to connect with the encoder and the other stuff. Now moving to the end of it, where we have the compiled form of our project in which it was working. So let me just mm, show you that. Mm, just- So here we were testing our project, and we had compiled it all together, and all the components were placed. Uh, and here we use four motors instead of two, and the six IR sensor were used. If we see, so we can see that after giving it a power supply, this was the wire of power supply that was given to our robot, and we can see that it is sensing the line like and giving a high output to motors, and then it follows the curved part like that. So here it is following correct correct part of it. So this was the hardware part of our project. And if we move to the challenges that we faced here, so the challenges were that it took us a lot of time in etching, and then while we were drilling the um, PCB board, then our drill bit was broken first of all, and then when the drill bit was fixed, and the holes were made quite wider than expected, and the pins were not fitting in it, then we had to use another drill bit and to drill it. And then another challenge was that our IR, that our mic controller was not properly fixed or board. After 8 hours, sensors were not working properly. It was either giving a high input to the sensors or then to motor. But we encountered all these uh, hurdles and hardships by working together as a team who can lead you to the best possible ways. So this was the hardship that we faced, and the another hardship was that we were the cells and battery were draining so fastly because it needed a constant power supply. So to overcome that problem, we used um, a connector to give it a direct power supply to from our adapter to our PCB. So for to open that, we used a push button that was used to turn it on and then off. And along with it, we used it up to give it a power supply of the required amount, so that it can keep on moving, keep on rolling the track. So this was it. And one thing is missing. Let me show you that. So here is our Proteus PCB layout, in which here is our PCB. Sorry, here is our Arduino Advanced 560, and here are the several pins. And this layout was to be etched on a PCB board. And here we had the pins for ultrasonic sensor, and and these are the VCC and ground terminals for our IS sensors, and then VCC is for encoder 1 and encoder 2, and then ground terminals for encoder 1 and encoder 2. And here our sensors were connected. Here it was the most left sensor, then left sensor, and then these two were the center ones, and then right sensor, and then most right sensor, and these are all connected to Atmega 2560. And here were the pins for LCD module, which were recording all the information that was being perceived. And here we had our pin for encoder 2, and here was for encoder 1, that were there to see how many rotation were motors gonna take. And here we had pins for our SD card module, and then the SD card module was recording all the data that was being introduced in it. And then here was our we input, and this was all the PCB layout that was being used in our project. So this was all for this video, and this was all our project. In the end, our project was following the line accurately, and it was working as you have seen in this video. So in the conclusion, we can say that we learned a lot by this project. We learned how to manage our time, and we learned about the project management stuff, and then we learned how to design our proteus, and then how to we how to configure the IR sensor, and then we learned that how can we code on a microcontroller AVR technology. And then we learn about the designing of PCB board and then etching it. There were many processes that were included in this project, and this project was quite a lot helpful in understanding about the course and understanding about all the things. So that was it for this video. I hope you will like this video. Thank you.